Welcome to Lesson 20 on Samples and Populations. We're going to start with the key idea on page 440. So, we're looking at two words here, population and sample. So, population is an entire group of people or objects. A sample is just part of that population. All right? And so we use a sample to interpret the information from that sample and then make an inference based on whatever that information is. And a lot of times that information or that inference is about the entire population. We try to draw conclusions. So we can look here at a couple examples. Here for A, we have the students in a school and the students in a math class. Which one is the population? Which one is the sample? Again, it would be all of the students in the school is the population, whereas the math students are the sample. When we look at the C part here, we notice that it's 150 quarters, or all of the quarters in circulation. All of the quarters in circulation means every quarter in the country that is out there circulating. So obviously that is the whole population, and the 150 quarters is just the sample. We continue with key ideas on page 442, where we look at unbiased and biased. If you remember, biased shows some sort of favoritism, as unbiased does not. And so when we're looking at a sample, the unbiased sample is a representative of a population. It is selected at random and is large enough to provide an accurate data. So it can't be just one person out of 3,000, right? It has to be accurate enough of a sample, large enough to be able to provide that accurate data. A bias sample is actually going to be something that is not representative of the entire population. One or more parts of the population are favored than other parts. So again, within samples, we're going to have unbiased and biased samples. Putting this information to the test, we'll check example 1 on page 442. So it says you want to estimate the number of students in a high school who ride the school bus. Which sample is unbiased? A, 4 students in the hallway. B, all students in the marching band. C, 50 seniors at random. Or D, 100 students at random during lunch. Choice A, as we can see, is not large enough to provide accurate data. It's only 4 students. Choice B is not selected at random. Choice C is not representative of the population because seniors are more likely to drive to school than other students. And then choice D is representative of the population. It's selected random, and it's a large enough population to provide accurate data. All right, so looking at example 2 on page 444, it's asking us to decide whether conclusions are valid. So we're looking at this idea of wanting to know how the residents feel of your town about adding a new stop sign. So we need to determine whether this is valid or not. So A, it says you survey the 20 residents who live closest to the new sign. 15 support the sign and 5 do not. So you conclude 75% of the residents of your town support the sign. So this obviously is not valid because the sample is just the residents that live close to that stop sign. So they're going to be biased, possibly. And so if we look at B, it says you survey 100 residents at random. 40% of them support the new sign and 60 do not. So you conclude 40% of the residents of your town support the sign. This makes more sense. It is valid because it is a random sample and it is a fair enough size, 100 people. All right, in example 3 on page 443, we're going to put some of this information to work. So we can see that we have a pie chart off to the side, movies per week. So it's 1 movie, 0 movies, or 2 or more movies. And it says you ask 75 randomly chosen students how many movies they watch each week. There are 1,200 students in the school. Predict the number of students that watch one movie per week. So you have to first off obviously set up a proportion, and so you can see that where they took 21 over 75. The 21 is the 21 people that watched one movie. The 75 are the total people that they interviewed, that they surveyed for this. And so they set that proportion equal to n over 1200. The 1200 is in the denominator because, again, it's that total, right? And so then they can cross multiply. You get 75n is equal to 21 times 1200. And then when you solve for it, you get 336. So based on the survey, we can make an assumption, a prediction, that 336 students in the school watch one movie each week.